Hello, everyone, and welcome to part one of our lecture on chapter 6, which is all about sampling. How we get the participants in our studies and the ways that we sort of make sense of who we're including in our study and why. So, to begin, we need to start with some basic definitions of what sampling is. So, sampling refers to the procedure that is used by researchers to select a subset of the population that can be used to conduct a scientific study. So the sampling is the procedure itself. The actual subset of people who will be in your study is considered the sample. And this sample is considered to be a subset of the population used. So, by following different sample procedures, researchers increase the likelihood of getting a representative subset of the population as their sample. So, where the sample is the subset of people who will be participating in our study, the population refers to the entire group of people that are the focus of our study. So, for example, I do a lot of research in suicide and I do a lot of research in Colorado because I have a lot of data for Colorado adolescents. And I have a sample or I have a research population that is Colorado adolescents who experience suicidal ideation. My sample, that's the entire population of people that my study is applicable to. My sample would then be a subset of that population. So out of the, let's just throw out a rough number and say like 20,000 adolescents in Colorado who experienced suicidal ideations in the last 6 months, I'm going to have a small subset of them that become the sample of my study. So instead of saying there are 20,000, I'm only going to talk to 500 of them. And those are going to be the sample population or the sample set of people who are going to partake in my study. We also have the term representative sample. And representative sample is one that reflects the same features of interest as the entire population. So if that means that I want to conduct my study on adolescents who experience suicide in Colorado, I want that sample to be representative of the entire population. So the sample of people who participate in my study are going to reflect the proportions of people in the community. If there are people of more than one sex who are more likely to experience suicidal ideations, then I'm going to have more individuals who identify with that sex in my study. It's representative of the greater population. And the first step toward finding the best sampling technique is to determine the population of interest and to develop a sampling frame. So a sampling frame is a list of the entire population of the study. So that means it is all people who would qualify for your study based on your construct of interest. So for me, a true sampling frame would be a complete list of every single Colorado adolescent who has experienced suicidal ideations in the last 6 months. That would be a true sampling frame. Because the sampling frame is not always easy, we might have it a little bit more generalized and say all Colorado adolescents who have experienced suicide in the last 6 months. But we also have to establish a population of interest. And researchers have developed different ways to sample from a population even if a sample frame is not possible. And part of that is by looking at a population of interest. By saying, okay, I don't have the names for every single person who will qualify for my study, but I do have a general population of interest that I can use as a starting point. And sampling types can be divided into two large groups: probability and non-probability sampling. So probability sampling refers to when participants are randomly selected and a sampling frame is often used. So with probability sampling, randomization for the sample means that everyone in the population has an equal chance of participating in the study. It is common to use probability sampling in quantitative studies because these sampling measures are a better representation of the data that you are going to be gathering. And oftentimes, if you use probability sampling, you are going to result in a much larger sample size, which is also part of why probability sampling is a really good fit for quantitative research because you typically need larger samples in order to run your analyses. Non-probability sampling, on the other hand, occurs when participants are not randomly selected and a sampling frame is not available or may not be available. Non-probability sampling is more common for qualitative studies to use, and non-probability sampling often results in smaller sample sizes because you are not selecting people at random. You might have a little bit of a specific person in mind who you're asking to participate, and it just becomes a lot more narrow. So let's break down the common examples of non-probability sampling in this first half of our lecture, and in the second half we'll talk about the examples of probability sampling. So for non-probability sampling, this includes various techniques that do not include an equal chance of participation in the study. They often involve populations that are difficult to reach or where a sampling frame does not exist, and that's why we rely on these non-probability samples. The first non-probability sampling technique is what we call convenience sampling. And this technique allows a researcher to select any participants who are available to participate in a study, even if they are not representative of a population. Their participation happens by availability and accident, so it is also called accidental sampling. A good example of convenience sampling is here at CSU. We actually send out surveys to CSU students all the time. And we're doing it because they're convenient. They're right here, they're easy to access. And we might say we are getting CSU students and having them be a sample that is representative of all college students. But in reality, CSU students are not representative of the entire population because CSU as a campus is not like all other colleges on various fronts. So that's an example of convenience sampling. And particularly with inconvenience sampling, there is a method that is often coupled with it called pilot studies. And you use pilot studies as a researcher to design the best possible study that you can. And a pilot study is where you take your survey and you initially send it out to a small group of people and you get inquiries from them that will pave the way for a larger study on that topic. You do this by sending your survey out to, if you have a goal of sending it out to 500 people, you might start with a sample of 25 people and say, hey, here's my study. Can you pilot it? Tell me, give me feedback, and let me know what worked, what didn't work. And within that pilot study, we use them because they help us to ensure that we have well-conducted studies when they are larger. But also, pilot studies are cost-effective because they allow us to test different aspects of our study on a small scale before they are used on a larger group of people. So pilot studies are really helpful and particularly common within convenience sampling. We also have what's called snowball sampling, and this technique is used when participants are selected by word of mouth. So you might start a study with only one or a few participants, and those participants might be willing to help you find more participants to be in your study. So as each participant starts to be a part of your study, they give their answers, and then at the end they say, yep, I'm going to refer my friend to you to participate. That friend comes in, they refer you to another person that they know, so on and so forth. So just your sample size gets bigger because it's building on itself like rolling a snowball down the hill. It gets bigger as it collects more snow. And that's the idea with snowball sampling. One caveat to snowball sampling is that it may not be representative of the entire population because the researcher is selecting only participants who know each other or who are connected to one another in some way, even if it's informally. Like, hey, I just know you because we shop at the same grocery store, or we work in the same building but in different offices. They're still connected in some way, which automatically means that your sample is likely not representative of the greater population. Oftentimes, a researcher can start with convenience sampling and continue with a snowball sampling. So start with who's available, who's willing to participate in your study, who is just happens to be at the right place at the right time to participate, and then have them snowball and get more people. And a researcher should try to introduce as much participant variety as possible by encouraging participants to recommend people with specific characteristics to participate. So if you have a research study that's going and you've had all people who were assigned male at birth so far, you might say to the next person, hey, I'd like for you to refer someone who is assigned female at birth to help encourage that variety in your participant identities. We also have what's called perpessive sampling, or and this technique allows a researcher to select participants of interest for a study, and you as a researcher get to handpick who you want to participate in your study. You are selecting them with purpose. It is oftentimes also called judgmental sampling because you as a researcher are making a judgment about who should be included in your study, but also who should not be included in your study. Homogeneous sampling is a specific type of perpessive sampling technique in which participants are chosen based on a trait or characteristic of interest. So each participant in homogeneous sampling must have this one specific characteristic that the researcher is looking for. So you might say, I'm going to hand select my participants based on whether or not they have all experienced this one thing, or they all identify in this one way. And that is how we create a homogeneous sample. They are all similar to one another on this characteristic that we as a researcher have selected is of interest and is necessary for our study. We also have what's called deviant case sampling, which is another type of perpessive sampling, which focuses on unusual or very specific cases that are typically the outliers in other studies. So when you use deviant case sampling, you oftentimes have very small sample sizes because you are looking at a very small set of people. So an example of this might be in the research that I do research on suicide a lot. If I'm looking at all of the Colorado adolescents who have ever attempted suicide, the number of Colorado adolescents who have attempted suicide 7 or more times is very small. They would be considered the deviant case because they are the outliers compared to everyone else. And if I want to do a research study with only them, I would have to use deviant case sampling. And it's important to keep in mind, as a whole, perpessive sampling allows a researcher to pick participants according to the characteristic under the study, but that means that the results of the study generally can't be generalized to the greater population, and they have lower external validity, meaning they aren't generalized out to the greater population of people. It is really specific. So when you use especially deviant case sampling, you have to provide a solid definition and reason for why you need to conduct that study. And finally, we have what's called quota sampling, which is our final non-probability sampling technique. And quota sampling is a technique that compares different groups within the population of interest. So if you are looking at a sample or a population of interest and you want to compare within that sample or within that population, like I want to see how suicide rates change based on gender identity, based on sexual orientation, based on sex assigned at birth. I might use a quota sampling method to break up the group and be able to draw comparisons across them. Quota sampling is used in both quantitative and qualitative designs. And as a researcher, we need a sample that is of a predetermined quota to know when we need to stop recruiting participants for each quota. So we need to have some sort of sample or proportion that we are looking for so that we know when to stop. And there are different types of quota sampling. The first of those is proportional quota sampling, which occurs when the sample's representation of this is of the same proportion as it exists in the entire population. So if I'm wanting to compare individuals based on their sex assigned at birth on their suicidal ideations and attempts, I'm going to look at, in the population of Colorado adolescents, how many of those who experience suicidal ideations, what's the percentage that are assigned male at birth, what's the percentage that are assigned female at birth, and what's the percentage that's assigned intersex at birth. And whatever that proportion is in our greater population, I am going to replicate that in my sample. If it is 40% assigned female at birth, 50% assigned male at birth, and 10% assigned intersex at birth, I'm going to get quotas that are of that same proportion. I'm going to have 40%, 50%, and 10% respectively, because I want it to be an exact proportion of what's in the population. But you can also have non-proportional quota sampling, which uses a different quota from the one found in the population of interest, because the study's aim is to compare two or more different groups of people. So an example of this might be if there is a large discrepancy in our society for people who are assigned male at birth to people who are assigned female at birth to people who are assigned intersex at birth on their rates of suicidal ideations. Maybe I'm not interested in it being even to the population, but I want an equal number of people in each of those quotas so that I can draw meaningful comparisons across them. That would be an example of non-proportional quota sampling, because my sample does not represent what's in the population, but it allows me to draw meaningful conclusions across the samples. So our book has a couple of different examples of what this looks like, and I think these graphics are helpful. So the left one is an example of proportionate quota sampling, where you take the exact proportion of people in the population and you create those same proportions in your sample. If you have 6 stars and 6 circles, you're going to have 2 stars and 2 circles, exact equal proportions. But in non-proportional quota sampling, those amounts might be different. Even though you start out with what looks like maybe 10 stars and 10 circles, maybe in your sample you're going to have 6 stars and only 2 circles, because that is what gives you the meaningful numbers that you need to draw comparisons across these groups. So that's where we're going to pause our discussion on chapter 6. So join me for the second part of our lecture on chapter 6, where we're going to talk about the different types of probability sampling. I will see you all in the next lecture.